two steel plates, each 4-inch wide and 0.25 inch thick, reinforce a wood beam that is 3-inch wide and 8-inch deep. So the steel plates are attached to the vertical sides of the wood beam in a position such that the composite shape is symmetric about the z-axis. This has been illustrated here in this figure. So determine the maximum bending stress produced in both the wood and the steel if the bending moment is applied. Then we have known the modulus of elasticity of wood and steel. Okay, here we start from the original configuration. Then we need to transform them into the same material. Right? Of course, we have two choices. We can convert steel into wood or wood into steel. Right? Let's see what will happen if we convert steel into wood. Okay, and we're requested to calculate the maximum stress in wood and maximum stress in steel. Okay, to calculate that, we need to make a choice, and our choice here is to convert steel into wood. Okay, what does this mean? It's meaning that we're using an n, right? The n value, as we have selected wood as the base material. Right? It's E wood. Above it will be the E steel. Here you get a 30,000 over 2,000. This is a 15. Okay, the n value is 15 to to convert steel into wood. Right, so here after this conversion, we can try to find the y bar and I. Right, so the y bar is actually easy. Right? If you have understanding this thing, so the y bar can be easily found. Right? If you cannot look through the miserable, then just repeat the process. Right? Use the equation and the table. Right? It's sum ai yi over ai. And here we have three areas as denoted here: area 1, area 2, area 3. Okay, so the table 1, 2, 3. Right, so what is ai and what is yi? So you can see that the y1 is what? Y1 from the bottom to there, the y1 is just half 8, right? Half 8, that will be 4. How about y2? Local centroid to the bottom, also 4. Right? And 3, also 4. So do you have to calculate A1, A2, A3? No need, right? It doesn't matter, since no matter what are their areas, the average value will still be 4, right? So this is just 4. And let's look at the I. I is just sum ICI plus AI DI square. And the table 1, 2, 3. The AI, again, it doesn't matter. This will not use it because when you calculate DI, you will see what this yi minus y bar. 4 minus 4 equals 0. Right? 0, 0, all 0. So AI DI square will be 0. Right? So we only need to calculate ICI equals BH cubed over 12 and add them together. Right? So the first one, area 1, right, width is 3 here. 3 times 8 cube over 12. You get 128. Right, second area, 3.75 times 4 cube over 12. This will be 20. And area 3 will be the same as 2, right, 20. So here will be just 128 plus 20 plus 20. You get 168 inch to the fourth. Okay. Then this is our step 2. Then step 3 will be, well, we can directly calculate the maximum stresses. Right, the maximum stress in wood, since this is the base material, so we do not need to do any conversion back. Right, this we can directly calculate it. This will be m times c over I. It will be 50 kips inch. Right, this is 50,000 pound inch times the c value. C is what? 4, right? 4 inch over 168 inch to the fourth. We get 1190 psi. Compression or tension that depend on the bending moment, the sign of bending moment, right? And maximum stress in the steel. Here we need to do a conversion back, right? As this would be N times mc over I. So B N is what? N is 15 times 50,000 times the C value here. Right, this is a half of 4. This is 2 over 168. So be 8930 psi. Okay, so it's critical to remember this n, right? Since we need to convert it back from wood into steel. Okay, the real cross-sectional area is much smaller by a factor of 15. So we need to multiply it by 15 to get a larger stress. Okay, so in this example, we just tried to convert steel into wood. Then how about if you convert the wood into steel? So what do you get? Okay, this is in another transformation. You can also that this will be the method 2. I convert wood into steel. So what kind of cross section you will get? You will get a much narrower central piece. Right, this kind of section. Right. Though the size of the steel will not be changed, will be the same, but the width of the wood will become much smaller. Right, since in this case, the width here will be from 3 times the n will be what? N will be 2,000 over 30,000. Right, this will be 0.2 inch. Okay, you can try to do this by yourself and solve the whole thing, and then check if you can get the same result as here. Okay, if you can get the same result at these two values.